So today we are learning about parallel and perpendicular lines. Parallel should sound familiar. We learned about this in Unit 5 when we talked about systems of equations. Perpendicular lines should also sound familiar, but we haven't talked about this year. You've probably heard it in 8th grade. So before we start, I'm going to do a quick recap of what we already know about what we're learning today. You do not need to write this down unless you really want to. So in Unit 5, we learned about systems of equations. A system is when there is more than one equation, like you see here. Note that they're both in slope-intercept form. Which is y equals mx plus b, where m is our slope and b is our y-intercept. So the first system that we learned was about intersecting lines, and we said that wherever intersecting lines touch, this is the solution. So we constantly tried to figure out where are the lines touching. For intersecting lines, the most important thing is that they had different slopes. The y-intercepts did not matter as much. They just had to have different slopes. Then we learned about systems of equations that had no solution. They had no solution because, like these two lines, they will never touch. And they will never touch because they are parallel. We can see that by looking at these two lines, that they are parallel, and we can see that over here in the equations because they have the same slope. They have the same slope, and they always have a different y-intercept. The y-intercept was very important in this case. The last thing we learned about in Unit 5 was infinitely many solutions, and this is when there was a system of equations that were exactly the same. So over here you'll see that one line is lying directly on top of another line, and we can also see that in the equations because they have the same slope and the same y-intercept. So now we will talk about parallel lines, and we will recap this again. So again, parallel lines never intersect. Parallel lines have the same slope with a different y-intercept. So I'll just use the same example I gave before. If we were going to put the two equations in slope-intercept form, so y, we could say y equals, let's say, negative 2x plus 3, and y equals, now same slope, so negative 2x, different y-intercept, plus 4. So I know these are parallel because they have the same slope with a different y-intercept. Now we're going to add perpendicular lines. This is like the fourth type of system of equation that we haven't talked about yet. So perpendicular lines are special because, as you'll see in this picture, line T and line U form a right angle. You should remember that this little tiny box represents a right angle, and the measure of a right angle is always 90 degrees. So over on the right-hand side, we'll write this in: perpendicular lines intersect to form a right angle. And now the slopes of perpendicular lines are the negative reciprocals. This is the new big vocabulary word and concept that we're learning today, and I'm going to unpack it below. So a negative reciprocal, they have different signs and are flipped fractions of each other. So we're going to do 3 examples. The first one, I'm just going to focus on the slope. So negative reciprocals refer explicitly to the slope of a line. So let's say we had a slope of 2/3. the negative reciprocal of 2/3 would have to have a different sign, and sign is referring to positive or negative. So because this is positive, then my negative reciprocal will be negative, and then it has to flip the fraction. So instead of 2/3, it'll be 3/2. These are negative reciprocals of each other. If we graphed these as slopes, they would create something that looks like this. Two different lines that intersect to form a right angle. So now let's put them into an entire equation. So we'll use the same ones. Y equals 2/3 x plus 3, let's say, and y equals negative 3/2x plus 4. So this is an example of slopes that are fractions, which are a little bit easier. We're also going to encounter slopes that have a whole number. So let's say we had an equation that was y equals 2x plus 3. The slope is 2. The line that would be perpendicular to this line would have to have a slope that is a negative reciprocal. So it would have to be a different sign, and it would have to flip the fraction. Those are the two main things. So if this is positive, then we know that the next slope has to be negative. That meets the first criteria. The second criteria is flipping the fraction. So this is not a fraction, as you can see, but we have learned that whole numbers can always have a 1 underneath to create a fraction. So therefore, the flipped fraction of this would be 1/2. Negative 1/2 and 2 are negative reciprocals of each other, which means they create a system of equations that when graphed has a right angle. And again, the y-intercept, I'm just going to put plus 2. It could be the same number. The most important part is the slope. Lastly, intersecting lines. This should be a no-brainer. Intersecting lines intersect. But if they do not form a right angle, then they are neither parallel or perpendicular. And intersecting lines, the slopes are never equal, because if they were equal or the same, they would be parallel. So they're never equal, and the slopes are never negative reciprocals. Because if they were negative reciprocals, then they would be perpendicular lines. So again, intersecting lines do not form a right angle, and they are not parallel.